Hello and welcome to Chemwonders. Today we are going to start a new series of videos on reaction mechanism in organic chemistry. To start off, we will discuss nucleophilic substitution reactions. First, we need to understand what substitution reactions mean. Reactions in which an atom or group of atoms in a molecule is replaced by another incoming atom or group of atoms are known as substitution reactions. It means that in a substitution reaction, a group of atom or an atom already present in a molecule is replaced by another atom or group of atom that is coming from outside. Now, substitution reactions could be of different types because we are studying or discussing nucleophilic substitution reactions here. So let's try to understand what nucleophilic substitution reactions mean. So as you already saw that substitution means replacement. A group that is already present in a molecule is replaced by an incoming atom or group of atom. So if the incoming group of atom or an atom is a nucleophile, then we say that the substitution reaction is a nucleophilic substitution reaction. I hope you all know what a nucleophile means, but just to remind you, it is a species which has a negative charge on it, or it may be neutral, having a lone pair or excess electrons. So a nucleophile literally means nucleus loving. So anything that will have an excess of electronic density will obviously be trying to look for an electron deficient center. Now nucleus here is symbolic, and that means anything that has a positive charge or has deficiency of electrons, just like a nucleus which has a positive charge because of protons. So a nucleophile means anything that has excess electrons and it is looking for any center or atom that has a deficiency of electrons. Now, this is a general reaction that shows how nucleophilic substitution reactions proceed. So we have a molecule Rx. X here is any living group. It could be a halogen or it could be any other good living group. When this molecule reacts with a nucleophile, and you can see here this nucleophile is shown with a negative charge. Now, because it's a nucleophile, it will fancy attacking any electron deficient center. And if you look at this molecule, this R group is attached to an X. Now, as I told you, X could be any good living group, and usually it's a halogen or any group that has an oxygen or a nitrogen in the structure. So this R group, which has a carbon atom attached to this X, this bond between R and X is polar, and the electron density is more towards this X group, and that is why this R group or the carbon is left electron deficient. So this nucleophile will try to attack the R group, expelling X from the molecule in the form of a negative anion. So the charges on the left and right hand side are similar in both cases. So we have the formation of a new bond, this time between this R group and the nucleophile. Now, nucleophilic substitution reactions could be of different types, or in other words, we can say that these nucleophilic substitution reactions follow different reactions pathways or mechanisms. The first one is a unimolecular nucleophilic substitution reaction. We call it SN1 in short. It's a unimolecular reaction which is nucleophilic in nature, and of course it involves substitution reactions. Next is a bimolecular nucleophilic substitution reaction, which we call the SN2 reaction mechanism. The third one is a nucleophilic substitution internal mechanism, or we can call it the SNI mechanism. The fourth one is a type of reaction mechanism which involves the participation of a neighboring group during the reaction. Then we have the SN1 prime reactions and the SN2 prime reactions. So these are the different types of nucleophilic substitution reactions that follow different pathways or mechanisms. We will discuss each of these mechanisms in detail in the upcoming videos. So stay tuned and wait for the upcoming videos on nucleophilic substitution reactions. Thank you so much for watching. See you next time.